Countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Selamat datang ke Pusat Tuition Ayu. Bermula percuma, selamanya percuma. Okey, pada hari ini kita masih lagi bersiaran daripada Kimia Perayu dan saya Cikgu Shannon bin Awi sebagai moderator pada hari ini. Dan pada hari ini kita sebenarnya bersiaran di bawah teacher Vivi Lau. Teacher Vivi Lau adalah kita punya penceramah ataupun presenter sebenarnya pada hari ini. Okay. Dan teacher Tang adalah control host pada hari ini dan teacher Kong sebagai pemerhati pada hari ini. Dan adalah diingatkan kepada semua pelajar supaya menggunakan kata-kata yang baik semasa menggunakan ruangan chat. Gunakan sebaiknya untuk bertanyakan soalan. Dan di akhir siaran kita nanti, kami akan berikan link sijil, link sijil penyertaan. Jadi tanpa melengahkan masa lagi, rasanya saya akan serahkan majlis ini kepada Teacher Vivi Lau dengan tajuknya Periodicity. Dengan segala hormatnya dipersilakan.
Terima kasih. Thank you very much, Teacher Shannon. Good afternoon, teachers and students. I'm Teacher Vivi Lau. Today, we're going to learn about periodicities of periodic tables. So first, let me introduce myself. My name is Lau Chai Wee. I'm currently working in Pusat Tingkatan SMK Tinggi Kelang. Okay, these are our PU teammate. So the first one, we have mathematics department. We have teacher Im, who is the ketua panitia, and the other members. Next, we have biology team. We have Cikgu Faiza as the team leader and the other teachers. Then we have physics, which is led by Madam Rosmaya. We also have accounts and economy, which is led by Madam Fizi. Last but not least, we have chemistry, which is led by Cikgu Shannon. Then we have Teacher Tang, our control host today, and Teacher Kong as our observer today, and Cikgu Mama Kimia. So let's start our lesson. So today we are going to look at physical properties of period 2 and period 3. Okay, so these are the learning objectives. Okay, so this is a periodic table of the elements. Okay, so for periodic table of elements, we have S block. Okay, S block is the group 1 and group 2 the metals, alkaline metal and alkaline earth metal. Then we have D block. So the periodic table of elements consists of 4 blocks, S block, D block, P blocks, F blocks. So depends on the valence electron. So S block, the valence electron, general valence electronic configuration is NS2. Then D block is N 3 D, D4S. ND something, okay? So here we have, for example, 3D here, the electronic configuration, the element here is 3D 4S, 4S something, okay? So it's ND and S something for the D block, okay? So the valence electron has at the d orbitals, so it's a D block. Then P block we have the general electronic configuration, and S2 and P1, okay. Then for F block we have F, okay. The valence electron we have F electrons, okay. So let's look at next slide. So today we will discuss about melting point. So melting point, boiling point, and enthalpy of vaporization, the trend are the same, okay. So we also will discuss atomic size and ionic size, electrical conductivity, and ionization energies. Okay, so these are the general trend of the across a period. Okay, so periodicity show the trend across a period, and also we have physical properties and chemical properties across a period. So we say periodicity. So today we just discuss about physical properties. Okay, so while we discuss across a period, sometimes we have to look across down the group also, okay, to compare the trend. Okay, so we have atomic size, okay, ionic. Then we look at the here didn't show melting boiling point. Then we have properties of the metallic character or non-metallic character. We will not discuss today. Okay, so we have ionization energy later. Okay, and the electronegativity. Okay. Okay, so these are the all the physical properties. Okay, we will go one by one. Okay. So these are all the summaries properties. Okay. Period 2 and period 3. So let's look at the first one. Okay, let's discuss the first properties, atomic size. So going down the group is atomic size increase. Then going across from right to left, the atomic radii also increase. Okay, this is increase. So normally we discuss is going across the period from left to right. So from left to right is decreasing. Then the atomic radii is decreasing. This one is increasing. Increasing. So you can see from here. So the across the period, the size decreasing. Then going down the group, the size increasing. Okay, so this is a graph for all the periods. Okay, so this is period 2 and period 3. Okay, so generally decreasing. Okay, so we focus on period 3 now. So going down, going across the period 3. So the atomic size decreasing. Okay, so first you have to understand what is atomic size. So atomic size is 1/2 of the average distance of D. Okay, the formula is D between the two covalently bonded atoms. So atomic radius is equal to D over 2. Okay. Okay, so the factors affecting atomic radii we have effective nuclear charge and the screening effect. So effective nuclear charge is the nuclear charge. So that is nuclear charge or proton number minus the number of inner electrons. So number of inner electrons is actually screening effect or sealing effect. So sealing effect is actually the inner electron repulsion experienced by the valence electron. So the effective nuclear charge is the net attraction experienced by the valence electron. Okay. So this is a diagram show the nuclear charge. Actually, is a nucleus. So it's a proton number because the neutron no charge. Okay, so across the period, the nuclear charge increase, okay, because number of proton increase. Okay, so effective nuclear charge also increase, because the proton number increase, okay, but the inner shell electron remains almost constant across the period. Okay, so we look at the explanation. For the period 2 and period 3, the atomic size decreases steadily when the proton number or atomic number increases from group 1 to group 17. Okay, across the same period, the nuclear charge number of proton increases, but the screening effect remains the same because the electrons, since the element of the same period have the same number of cell electrons, okay? Therefore, the attraction for the valence electron increases and the atomic size decreases, okay? So effective nuclear charge increase, because nuclear charge increase minus screening effect almost constant, so effective nuclear charge increase across the period. Okay, so this is a summary in the chart form, easier for you to memorize, okay? So across the period, proton number increase, okay, effective nuclear charge increase because number of proton increase and the inner shell electron constant. So stronger attraction between the nucleus and valence electron. So atomic size decrease. Okay, going down the group is different. So going down the group, the atoms get bigger. Okay, the atomic radius increases because element have extra shell of electron, compared to the one above it. The valence electron not only further but also screened by more inner electrons, so screening effect increase. So effective nuclear charge is the nuclear charge minus the screening effect. Now screening effect increase, so effective nuclear charge will decrease. Okay, so the valence electrons are not held so tightly by the nucleus. So atomic size increases. So this is a summary. So going down the group, the energy level increase. So number of cell, okay, number of cell increase. So in inner electrons, inner orbitals increase. So screening effect increase. Okay, inner electron increase. So weaker attraction between the nucleus and valence electron. So atomic size increase. Okay, next we look at ionic size. So ions is formed when the element accept electron. So for the non-metal, they will accept electron. For the metal, will remove electron. Okay, so non-metal will form negative ion, which is bigger size than the element, because accept electron. Then the metal remove electron, so one cell is removed, so the size is smaller than the element. Okay, so you can see here. So the sodium ion is 116 picometer, so smaller than the sodium metal. And the fluoride ion is 119 picometer, is bigger than the 71 pm for the fluorine atom. Okay, so across this is a graph for period 2 and period 3. So you can see going across the period, the ionic size decreases. Okay, then there is a drastic increase between the non-metal and non-metal, okay, positive and negative ion. Okay, same thing for the period 3, okay, between silicon and phosphorus ion. Okay, so we focus at period 3 now. Okay, so across period 3, from sodium ion to silicon ion, the number of electrons is the same. Okay, so they are called isoelectronic ions. Okay, so the ionic size increase effective nuclear charge. Okay, then for the non-metal here, they also have the same number of electrons. Okay, phosphorus ion to the chloride ion. Okay, so you can see the electronic configuration for the non-metal is bigger than the number of cells, more until 3, energy level 3, more than the metal. So they are isoelectronic species. So what is isoelectronic species? Means they have the same number of electrons. So they can be atom or ion. So ionic radii will decrease from the for the this one period 2, oxide ion to aluminum ion. Okay, so they are isoelectronic ion for the sodium until aluminum ion. Okay, so it's 2,8, and this one is so 2,8 is 1s2 1s2 2s2 2p6 so they become octet. So this one is 1s2 2s2 2p6 3s2 3p6. Okay, so explanation. So across the period 3, the ionic radii decrease because of the number of electrons remains constant, but the number of protons increases from sodium ion to aluminum ion. So the nuclear charge increases, but the screening effect remains the same since the ions have the same number of cells of electrons. The charge increases, therefore the attraction for the valence electrons increases and the ionic radii decreases. Okay, similarly for the sequence from the phosphorus ion to chloride ion, the ionic radii also decreases. Okay, because they have same number of electrons, but the nuclear charge increases. Okay, so the negative ion are larger than the positive ion because they have extra one cell of electrons, and the nuclear charge is less than the number of protons is less than the number of electrons. Hence, the attraction for valence electrons by the nucleus is generally weaker. Okay, now we have the first question for today. Okay, so same like last time. You go to first. Okay, so you go to classpoint.app, then you enter this class code 51664. 51664, then you can key in your answer for this one. Okay, so I minimize this one. So 51661. Okay, so you have to list the elements in order of increasing atomic size. Okay, so those who have a problem access the class point, you can just type your answer in the chat box. Okay. Okay, so I wait until 2 minutes. No, I will stop the response. Stop correlating the response. Okay, I think I close submission now. Okay, so now we have one answer from Ellie. Lithium, chlorine, silicon, magnesium. So very good. So I close submission now. Okay. So the answer is correct. Okay. Any other answer from the chat box? Cikgu Shannon? Got another response. See. here only see one. So, Cikgu Shannon got any other answer? No, huh? Okay, so never mind. So, Ellie, you are correct. Very good. So, your answer is correct. Okay, we look at the next question. So, this time you all can draw on the slide. Okay, you also use a glass point. Okay, so you can just draw on the slide. Okay. Circle the larger circle the larger atom in the pair, each pair. So we have 3 pairs here. So you just circle the larger atom or ion. Okay, so this one has correlation or ion in each pair. Larger atom or ion in each pair. Okay, I see 2 students here, so I wait for one more response before I stop collecting the response. Cannot access. Okay. So we look at the response. Okay. So correct. So them okay, very good. Okay, any other response? Okay, no more response. Okay, so very good. So your answer is correct, Ellie. Any other answer from the chat box, Cikgu Shannon? No answer. Okay. So don't have. Okay, never mind. We go to the next subtopic. Okay, now we go to melting and boiling points of period 2 and 3. So here show the graph. So we focus on melting point because actually melting point, boiling point, and enthalpy of change of vaporization, the trend explanation are the same. Okay, explanation for the trends are the same. So we look at melting point only. So across the period, you can see here there are drastic change in the melting point. Okay, this is because of the structure of the elements. Okay, so we have melting point increases from lithium to carbon. Okay, lithium to carbon, then rock. Okay, so melting point is very low for the non-metals. Okay, same thing for period 3. Okay, the melting point increases. Okay, then very high until very high at the silicon. Okay, then rock. Okay, for the non-metal become very low. Okay, so this is because of the structure. So you can see here is this one is a metal. Okay, then this one also sodium magnesium element, they are metals. Okay, so this one is non-metals. Okay, so metal they have giant ionic structure, so it's very strong. This one is element, giant metallic bonds, so it's very strong. Okay, then carbon has giant covalent molecular structure for the diamond, graphite. Okay, so very high melting point. Silicon also have giant covalent molecular structure. Okay, then the non-metal they have weak van der Waals forces between the molecules. Okay, so you can see non-metal weak van der Waals forces. Then the silicon carbon they have giant covalent molecular structure. So strong, you have to break the strong covalent bonds. Then metal we have relocalized electron. Okay, so negative is relocalized electron, and the electropositive metal form the ions. Okay, so strong metallic bond between the electrons, relocalized electron, and the positive ion metal. Okay, so this is the structure. Okay. So in the atom, you have to write sodium, magnesium, aluminum has a giant metallic structure. Silicon giant covalent molecular structure. Then the phosphorus until argon, they have simple covalent molecular structure. Okay, then strong metallic bond between the atoms for the sodium to aluminum. Then strong covalent bond in the silicon giant covalent molecular structure. You have to break this bond, only can melt the substance. Okay, so that's why the melting point change very drastic across the period. Okay, so these are the explanation. If it come out in essay, you have to write like this. So the explanation like this now. Okay, so here we have explanation increase from the sodium to aluminum because of number of electrons, number of relocalized electron increases. Okay, or you can write the configuration. So sodium is 2s2 sorry, 2s1, magnesium is 2s2, then aluminum is 2s2 2p1. Okay, you also can write the electronic configuration in the exam. Okay, so essay you write as many points as you can, because they will not minus your mark for the wrong points. Okay, so you just write as many points as you can, but subjective you must write correct answer. Okay, so silicon giant covalent molecular structure, so have strong silicon covalent bonds, so a lot of energy is required to break the strong covalent bonds. Okay, between the atoms. So you must write this one between the atoms. So metallic bond also between the atoms. Okay, then non-metals, simple covalent molecular structure with van der Waals forces, you have to write between the molecules. Okay, must write the weak, and just now this one must write the strong. Okay, strong covalent bond. Okay, got the strong here. So must mention strong. Okay, then here got mention the size. Okay, because van der Waals forces depends on the size. Okay, so the strength increase when the size increase, more electron to relocalize. So so the melting point will increase from phosphorus to decrease from phosphorus to argon, because the size decrease across the period. Okay, so this one is oxide. Okay, this one is careful. This one is oxide. So for oxides, magnesium oxide has the highest melting point. Okay, because of the this one is because of the structure, ionic compound structure, more costly pack. So magnesium oxide has the highest melting point. Oxides. Okay, that one is not element. Oxides. Okay, so I think what's the time now? So Cikgu Channel, do you want to take a break before I continue the?
Maybe
Okay.
we already 30 minutes already. Maybe we can take a break for a while.
Okay, so we take a break.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma, mestilah Akademi YouTuber.
Okay, welcome back. And Teacher Vivi Lau, the floor is yours.
Okay, so I continue. Electrical conductivity of period 2 and 3 elements. Okay, so electrical conductivity, the unit is this one. You have to memorize the unit because got 1 year the exam come out, you have to draw the graph, then you have to mention the unit of electrical conductivity. So the unit is Kelvin per ohm per cm. So electrical conductivity is the amount of electricity that can be conducted by a substance under standard condition. Okay, so if the exam asks you to draw period 2 and period 3 combined in one graph, you have to use the same axis, okay, to electrical conductivities for 2 periods, okay. So you can see here, so the conductor, okay, so the this one is a photon number 3, okay. Oh no, this one is number of element. Okay, it's the third one, third element in the period. Okay, so this one is either period 2 is boron. So for period 3, the third element is silicon. Okay. Oh no, this one is I write here. This one is number of valence electron. Okay, write only mention only number of electrons. So this one is period 3. This one period 2. Okay, so this one is lithium. Lithium, beryllium, boron. Okay, so this one sodium, magnesium, aluminum. Okay, so this one is silicon. So here carbon. Okay, so this one combined already. So you have nitrogen, oxygen, fluorine. Okay, then so phosphorus, sulfur. Okay, so you can see across the period, the electrical conductivity increases for the metal, okay, increases, okay, because number of valence electron increases. So more localized electron to carry the electricity. Okay, then the metallite, okay, boron metallite, then the electrical conductivity not so good. Then silicon, carbon, they are semiconductor. Silicon semiconductor. Carbon, we have the graphite. Diamond is not conductor. So you have to explain the carbon has diamond, not conductor, insulator. Graphite is a conductor, not so good, but still can conduct electricity. Okay, then the non-metals, they are insulator. Okay. Okay, so this one is focused at the period 2, electrical period 2. So it's a bit different. So you follow this one higher a bit. Okay. Then the carbon, this one I think mentioned for diamond, so 0. Okay. So depends how the question asks 0. Okay. Okay, then the period 3. Okay, period 3. So increase from sodium mentioned to aluminum. Okay, silicon semiconductor. Okay, so the explanation, where is it? Okay. Sorry, I think the slide run away. Okay, so the explanation for electrical conductivity, I read over here. Sorry for the okay, sorry, the slide run away. Okay, so the explanation, so you have to explain the across the period, the conductivity increase from lithium to beryllium, okay, increase, okay, because they are metal, so they have metals, okay, strong metallic bonds, so means they are good conductor. So you have to mention all the points for essay. Okay, then beryllium better because of the more relocalized electron. Okay, so you write out the electronic configuration. number of valence electron higher, so more relocalized electrons. Okay, then mention the carbon we have graphite. Graphite can conduct electricity. Actually, fluorine also can. Okay, because graphite has relocalized electron within the layer. Okay, in the between the layer structure. Okay, or you can write within. Okay, within the layers. Okay, boron is a semiconductor because it's a metalloid. Okay, so here has a explanation using the energy band theory. Like actually energy band theory not in the syllabus, sorry, but you easier to explain using the energy band theory. Okay, so for semiconductor, there's small gaps between the valence band and conduction band. That's why the electron can carry electricity in the conduction band. Okay, so you can increase the conductivity by increasing the temperature or doping with other elements. Then non-metals, insulators. So explanation is you can just write, you no need to use energy band theory. Just write no relocalized electron. No relocalized electron. Okay. So if you want to use energy band theory, means there are big gaps between the conduction band and the valence band, or you can just write no free moving ion or no relocalized electron. Okay, then we look at electronegativity. Okay, so electronegativity is the ability to for the element to attract electron in a covalent bond. Okay, so must in the covalent bond. So the greater the electronegativity, the greater the ability to attract electron. So this one you can see hydrogen chloride. Okay, so chlorine is more electronegative. So the straight electron pair will go nearer to the chlorine nucleus. Okay, so this one will become negative, partial negative charge. Then this one partial positive. This one you learn in semester 1. So for semester 2, this one electronegativity not so important. So the fluorine has the highest electronegativity. So across the period, electronegativity increases. Okay, because size decrease, so greater attraction. Okay, nuclear charge. Okay, so that's why electronegativity increases. The screening effect is almost constant. So effective nuclear charge increase, so greater attraction towards the valence electron. Then going down the group electronegativity decrease. Okay, because the atomic size increase. Okay, so the steering effect increase, so effective nuclear charge will decrease, so less ability to attract electrons. Okay, so this is a graph. Okay, next we look at the this one is just now electrical conductivity. I haven't moved this slide, so it's the same for period 3. Okay, this one is period 3. Okay, so the from sodium to aluminum. Okay, metals. So same explanation like just now. So metals, they are good conductor because they have relocalized electron. Then you mentioned aluminum stronger ability to conduct electricity. Okay, because of the more relocalized electron than the magnesium and sodium. Okay, latest number of valence electron. Okay, then silicon is semiconductor. Okay, so metalloid. So same like just now. Okay, so phosphorus, sulfur, chlorine, argon, non-metals. Okay, so no relocalized electron. Okay, okay. Last we look at ionization energy. Okay, so ionization energy across the period. Okay, ionization energy increase. So increase. Okay, going down the group, ionization energy will decrease. Normally we look at going down the group. Okay, decrease. So going up is increase. Okay, so we can use ionization energy to predict the electronic structure. So first you have to know the definition of ionization energy. So first ionization energy is the minimum energy required to remove 1 mole of electrons from 1 mole of the atoms of an element in the gaseous state. So you must mention this one, 1 mole, okay, electrons. So this one, no S, from 1 mole of atom, okay, no S here, of an element in the gaseous state, okay, the keyword, actually should write under standard condition, okay. So example, if the question give example, you use the example given, or if the question asks you use an example to define first ionization energy, so you have to give example. So have to write physical state in the equation. So sodium form the sodium ion, okay, positive one, because this one is first ionization energy. So remove 1 electron only. Okay. Second ionization energy means the energy required to remove 1 mole of electron from 1 mole of singly charged positive ion in the gaseous state. Okay. Okay, this one just now incomplete. To form 1 mole of unipositive ion. Okay, so this one is to form 1 mole of, okay, doubly charged ion. Okay, second ionization energy of sodium, for example, you look at the equation. Okay, for this chapter, the definition not so important because this one is in the chapter thermochemistry, chemical energetic for the definition over there. Okay, so this chapter, this one not so important, but I go through. So the energy required to remove 1 electron from 1 mole of unipositive charged ion to form doubly charged ion. Okay, so factors affecting the magnitude of ionization energy. So there are 3. Atomic radius, okay, atomic radius, sealing effect, okay, effective nuclear charge. Okay, so first one, so when the atomic radius is big, so means the attraction will be weaker, okay, so lower ionization energy. So when the sealing effect is high, so means more inertial electron, so means the attraction of the nucleus to the valence electron weaker, so low ionization energy. Okay, so the effective nuclear charge is the result, okay, from the nuclear charge minus the sealing effect. That's right. So when the effective nuclear charge is high, so the attraction is stronger, so higher ionization energy. So there are factors. So now we look at across the period. So across the period, proton number increase, right? So effective nuclear charge increase. Why? Because just now you learn the nuclear charge increase, but the sealing effect constant, remain constant. So effective nuclear charge increase. So strong attraction between nucleus and valence electrons. So atomic size decrease. So more difficult to remove the valence electron. So first ionization energy increase. Okay, so this one is down the group, okay, because we discuss across the period, so you have to know down the group. So down the group, the energy level increases, principal quantum number increases. So additional inner electrons, okay. So sealing effect will increase, okay, because number of inner electrons seal the valence electrons increase. With so weaker attraction between the nucleus and the valence electron, okay, because this one result in the lower effective nuclear charge. so weaker attraction between the nucleus and the valence electron. So atomic radius increases, so easier to remove the valence electron. So first ionization energy decreases when going down the group. Okay, so we look at the anomalous behavior of the first ionization energy. Okay, so these are the graph that show two periods. Period period 2 and 3. Okay, so generally it will increase, but anomalous means for certain element, okay, the ionization energy is lower. Okay, so we say anomalous. So should be generally increase, but we have some decrease in the trend. So you have to explain why the decrease between the group 2 and group 13, okay, and between the group 15 and group 16, okay. So we look at the explanation. So between the group 2 and group 13, because beryllium has this one group 2, so it has fully filled 2s, so this is stable. Then group 13, boron has partially filled, so more energy is required to remove electrons from beryllium because stable. Fully filled 2s2 is stable. Then partially filled, okay, the 2p one is at the higher energy level, so less stable, easier to remove. Hence, the first ionization energy of beryllium is higher. Okay, next you look at between the 15 and 16. Okay, so the explanation, nitrogen has half fill. So half fill you learn in semester 1 is extra stable. Okay, has extra stability. Okay, then boron has partially filled, so more energy is required to remove the electron from nitrogen, which has a extra stability half fill p orbitals. Okay, oxygen is has 2p4, so it has a electron repulsion, so it's easier to remove. So in the exam you just choose one, either this one or this one to explain your answer. Okay, that's why first ionization energy of nitrogen is higher than oxygen. Okay, so this is, you also can roll out. Okay, so this one is half fill, so extra stability. Okay, so extra stable. So, or you can use this one to explain. This one has electron repulsion between the electrons. Okay. Okay, then we look at period 3. So period 3 actually explanation is the same. Okay. So here I show very fast. So the generally is increasing. Okay, because screening effect almost constant. Okay, atomic size decrease. So for the attraction increase. So this is a general pattern. Okay, but discontinuity between the group 2 and group 13. Okay, because of the stable full subcells, extra cells. Okay, so difficult to remove, or you can use element to expand. Okay, higher energy. Okay, so not stable. So you just choose one to expand. So between the group 15 and 16. Okay, so the half fill stable. Okay, like just now, this one is phosphorus for period 3. Like nitrogen, so difficult to remove. Then, or you can use the electron repulsion in the sulfur one. Okay, so easier to remove. Okay, next we look at successive ionization energy. So for successive ionization energy, repulsion among the remaining electrons decreases when electrons are removed from an atom. So the remaining electrons are closer to the nucleus, so being pulled towards the positively charged nucleus. So I think this one, same one, you got learn why second ionization energy are very high compared to the first ionization energy. This one is a explanation because electron and the positive charge, okay, nucleus stronger attraction. So you need more energy to remove the third electron and the second electron. Okay, same thing for third ionization energy and so on. That's why successive ionization energy increases. Okay, so you can use successive ionization energy to predict the structure, or we say electronic configuration of the element. So means evidence for the cells and subcells. Okay, so we have two examples here. Okay, so element P and element Q. Okay, so we have two methods to calculate. Two methods to calculate. I show. Two methods to calculate this one. Okay. So these are the two methods. You use find the differences in ionization energy, or you draw the graph of successive ionization energy. Okay. Before that, we look at this one. Okay. How do you reduce the electronic configuration of an element and its position in the periodic table, okay, based on the successive ionization energy data. So later you roll the graph, you can see a big jump in the successive ionization data. So you from the graph you can reduce the electronic configuration and the position of the element in the periodic table. Okay. So why they have a big jump? Because okay, indicates because removal of the particular electron is from an inner shell, which has a stable normal gas electronic configuration. Okay. Also from the big jump, you can know number of valence electrons the element have. Okay. So we look at the first method. So first method you minus find the difference minus each successive ionization energy, you find the biggest difference. Okay, so the answer is group 14. Okay, after you minus, you will get this one, biggest difference. This one is a larger difference. Big difference, biggest difference. Okay, I use a triangle as a difference. Okay, so that's why it has 4 valence electron. So got 4 valence electron. Okay, so the electronic configuration, valence electronic configuration is NS2 MP2. Okay, then the second example, this one. So I will show you the answer. So you after you minus, or you can try to use your calculator and minus. So here is the biggest difference. Okay, so means it has 5 valence electron. So 5 valence electron, so it's group 15. Valence electronic configuration is NS2 MP3. Okay, so you see this one is 4,000 something, right? So the other, the difference is less than that. This one 4,000 something difference. So this one around 6,000 difference. Okay, so means this one is the highest difference, biggest difference. Okay, then this one is using the graph, using the graph method to determine the valence electron. Okay, so you can see here is a large difference. So here, between the first electron and the second electron, we have the large increase, a big jump. So means this is the valence electron. So between the first ionization energy and the second ionization energy, okay, we have a large difference. So the second electron is from the shell electron. Okay, so innermost stable electron. So 1 valence. Okay, so this one is sodium, is 2.8.1 at the arrangement. Okay, So means in STPM level is 1S2, 2S2, 2P1. Sorry.
Teacher Vivi Lau. What happened to the teacher Vivi Lau? Teacher Vivi Lau. Okay, I think something wrong happened to teacher Vivi Lau. So, Alhamdulillah, we are done with today's lesson. We have learned a lot from teacher Vivi Lau about periodicity. Congratulations to those who are able to follow our lesson from the beginning till the end. And thank you very much, teacher Vivi Lau, for such an interesting lesson. Now it's time for me to announce the passcode. The passcode for today is A5463. I repeat, A5463. And the presenter telegram is t.me/chaiwi99. t.me/chaiwi99. Please check the chat box for the certificate link. Okay, Teacher Tang, please give the certificate link. Please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to teacher Vivi Lau for giving you a free lesson today. Don't forget to click the bell button so you won't miss out any new video and live classes from teacher Vivi Lau. If you like today's class, then please click like and share it to your social media friends. Let's share the knowledge you received today with them. When you finish, type down in the chat session. Once again, I would like to thank to teacher Vivi Lau for the interesting lesson. Thank you also to teacher Kong and teacher Tang for being with us today. I think that's all for now. See you in another session. Please do remember, stay at home. Goodbye, everyone. Have a nice weekend. Merdeka, merdeka, merdeka. Bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.